Alright, in this video we're going to take a look at question 310 from your book. It says, do heavier people burn more energy? Metabolic rate, the rate at which the body consumes energy, is important in studies of weight gain, dieting, and exercise. The table below gives data on lean body mass and resting metabolic rate for 12 women and 7 men who are subject in a study of dieting. Lean body mass given in kilograms is a person's weight leaving out all fat. Metabolic rate is measured in calories burned per 24 hours. The same calories used to describe the energy content of food. The researchers believe that the lean body mass is an important influence on metabolic rate. Part A says make a scatter plot of the data for female subjects only on your calculator, which is the explanatory variable. So what I'd like you to do right now is, in a listen spreadsheet, if you could enter all of the data for the female subjects. Alright, so we have our data entered for the females and their mass and also their rate. So now what we want to do is we want to create a scatter plot of that. Relatively easy to do. All we're going to go to is insert data and statistics. Okay, you can get that from your menu, and you can see these are all females that we have. The F would indicate that. Okay, so it kind of is a data point for us with 3 different variables associated with it. Well, we're interested in 2 of those variables because all of these are females. We are interested in the mass and the rate. So the first thing is we need to know which one of our variables is going to be the explanatory variable, or if you want to think about it as the independent variable of a function. So that variable is going to be mass, because we're saying that their metabolic rate is dependent upon the mass that they are. So I'm going to put that as my explanatory variable, and then over here I'm going to put in rate. So this is what we have for a scatter plot for females of in terms of their metabolic rate compared to their mass. Alright, so the next thing that we want to do is, first of all, let's just talk about the explanatory variable. The reason why the explanatory variable is lean body mass is because of this statement right here. The researchers believe that lean body mass is an important influence over metabolic rate. So since it's influencing metabolic rate, or at least they think it is, that would be our explanatory variable. Okay. The second part of the question asks us to say, all right, is the association between the variables positive or negative? So let's take a look at our data points in the scatter plot, and we're just doing an eyeball look here. But it appears that as we move up the scale in mass, at the same time we move up the scale in metabolic rate. And so what that tells us is that there is a positive relationship. As one is increasing, the other one is increasing as well. So that would be considered a positive relationship between the 2 variables. Now, the second part of that question says, what is the form of that relationship? Well, it appears that our data is a little bit spread out, and kind of the eyeball approach is a little bit difficult. We'll look at kind of a different way to get a better gauge of that in a little bit. But in general, it's not a super strong, but there is certainly some strength to the relationship between metabolic rate and mass. Okay, like I said, we'll talk a little bit about how we can do that a little bit differently or more exact than just by doing an eyeball look at what the data is showing us. Okay, so the final question asks us to add the males to the data set. So if you could go through that data set and add the males as well. So as we're looking at this data set that we have in our notes activity, enter all the males now and do it in a separate listen spreadsheet so we can make a separate scatter plot just for the males. Okay, so once you've entered that data, it should look something like this. I just to make sure that we had a little difference in terms of our variables, I label these a little different than I did for the females. And then what I want to do is I want to go to inserted data and statistics again, and this time we're going to look at that for males. So I'm going to put rate M over here and mass M here, and you'll notice that we have a scatter plot, less data points, but also we'll notice that those data points, although it appears that they still have a positive relationship, it's not nearly as strong as it was for females. These females seem to be a little bit more linear, where these seem to be much wider apart. So there is a relationship, it appears, but not quite as strong as it was for females. So as I'm looking at this question, does the pattern for the relationships you observe hold? Yes, and then the difference would be it's just not quite as strong as it was for females.